Today we'll speak about API level fuzzing and particularly focusing on REST endpoints. We'll have like an initial context. I think it's important to have a bit of context before going into the fuzzing and understand a bit how a tool that I call CATS was built and how it ended up being a fuzzing tool. And in the second part, we'll go a bit into CATS, how it works, and what are some features that are currently developed. So initially, we'll just do a very short and simplified version of APIs. So there was SOAP at a point, and it was like the holy grail of API communication. It was like the best thing that could happen to distributed system at that point, and a way to make them communicate, and until it wasn't. And then it was REST, which again was like people do not like SOAP anymore, and they like REST more because it's simpler and easy to interact. And again, it was like the holy grail, but we have a lot of people which says it's still not like the ideal tool for the job. And we have now emerging, let's say, standards, which again promise to be the holy grail, but we'll see what happens in the next years. Well, I think it's usually that it's good to be in the middle. So I would say that there is like a common view that REST and JSON are still like industry standards, and then they account for like the majority of the APIs today. And even if there might be some criticism, it's still like something widely used and in focus. Now, there is another context set up here. So usually when you go to conferences, you hear a lot of buzzwords. So everyone is doing agile, everyone is doing big data, machine learning, everyone is doing Docker, cloud development, one-click deployments to production, CI/CD, all these buzzwords. And usually I feel like, am I the only one in the room that is not working with such cool stuff? And I think that was true for a while, but what we're seeing also as a company, and myself particularly, is that all those buzzwords are starting to become mainstream. And if you have like financial players moving towards that, so if you have like a typical bank which uses microservices, it means like it might be like an outdated technology, right? So what we've seen is that microservices are becoming mainstreams, and a lot of companies are moving towards that. There are a lot of companies moving towards cloud, so they either bring their legacy system to our cloud, or they modernize part of the organization and part of their systems to either building new capabilities or modernizing what they have. There is an API first thinking more and more. So because we have microservices, we usually do API first design, and we have services communicating with each other, and most of the business functionality are exposed to APIs. And we see security more and more brought into the actual, let's say, typical development lifecycle. So it's not like a side function that happens at some point before going to production. It's something that happens within the normal development activities. And of course, like we have the whole agile gods watching over this process. But what this process do is that it creates like a dynamic and fast-paced environment. So you get like a lot of pressure for the developer teams. So there is this needs to have frequent deploys to production. Like if you could deploy every minute to production, that would be great. We all know the stories like Amazon does deployment to production 10 times per second or so. It gets like most of the activities need to happen in parallel. So everything that happens, you develop, you test, you think about like different types of how you deploy that to production, like different types of checks, and everything needs to happen in parallel. Yet most of the business features are delivered iteratively, and that also applies to APIs. And they have like a huge pressure on the quality assurance part that you need to keep up with all the changes that happen and make sure that everything works well at any point. But there is also this, like, when I say we're agile, I've seen it used quite a lot like an excuse for not to do actual planning. So it's most of the time a lack of strategy for architecture development and like a testing also. And this usually leads to frequent and disruptive changes. So instead of understanding that building iteratively means you have a feature and you build it and you extend it with new capabilities, what most of the people get from Agile is like, we can change at any moment and we can introduce any disruptive change as we want. So this usually leads to even more pressure on people. Now, there are, of course, ways to reduce this waste that might happen for this. It's like you have this automation umbrella that it's like a mantra for you. So we have like continuous integration, continuous delivery pipelines, which will include a lot of quality gates to make sure that everything is verified. So you get like testing is automated at all levels. You have like security checks, which are being automated at all levels. You get your libraries being checked for vulnerabilities and so forth. You can do different level of testing. You can run unit integration, API, end-to-end performance, and so forth. And there is also good practice that you should use some sort of API spec capabilities for your APIs rather than just building them and putting them to the world. It's like a good practice to use something like OpenAPI, for example, where you have the specs and you can automate like the publishing of documentation and how the actual implementation of the service is being done. But it's not easy. It's like if you take a change, it's like an API change. You'll have like dev and test part. But what happens is that not all changes are created equal. So after the service will reach a certain maturity and your API will like reach a certain maturity, usually the effort required by dev might be quite significantly less than the test counterpart. So for example, if you take like a very simple change from payments, we have like a payload, which includes transaction details. And one of the changes is to introduce the 3DS capabilities to make the transaction more secure. But after a while, it says that, well, this is not quite up to the standards because we're not allowed to use numbers within field names. So we need to change that to, instead of 3DS with a number, which actually spell 3 and DS with capital letters. But after a while, it says now we need to be compliant with version 2 of the API of 3DS, and we need to include some additional capabilities within the API to account for like how the challenge will be made to the shopper or like introduction additional transaction ID details. And later to that point, we'll say that, yeah, but in order to maintain that better compatibility, we'll put all this new data into an additional structure, which will have its own details and so forth. And sometimes for dev, I mean, if you have the API quite mature, for dev it's quite trivial to change. I mean, you get like get 3DS, you change it to get 3DS with the spelling, and you get additional data and stuff with it. But for the testing, it's not always that easy. I mean, it might be for some of the stuff. So maybe this change will be quite easy for the testing. So you get like in your automation suite and you just replace all get 3DS with the get 3DS version with the spelling. But if there are changes, which for example, would change which are structural changes, so like you get boundary changes. The minimum is not 4, it's 10 now, and the maximum is not 11, it's 20. So those changes, even if for development, will just be out of the box because you just put the validation in. For the testing, it might mean changing 10 or 20 negative scenario testing. And that can happen independent on where you keep your automation tests. It's either in Postman, either in the backend through a framework, and so forth. And we know that people hate doing repetitive work. It's like in the nature to seek creative and exploratory stuff. So they don't like to just like writing like the 20th test today, which will send empty values inside the field. They like to think about like how they can break the software, but in a more creative manner. So like I want to find the tricky scenarios which are not easy automated to like sending all this repetitive values within the fields which are quite predictable. And if you're building like the 10th microservices, like okay, is that work again? I need to do all that. And if you do that like so many times, it's quite frustrating. So my thinking was like, what if you can build something which will take an API change, apply some magic, and it will update all the tests automatically. So instead of just going manually into that, you just apply the magic and the changes will happen. So this is how CATS was born. It was like a tool which aims to eliminate that boring part out of API testing. And how it works is that it needs an open API contract. And usually open API contracts, if are written well, you get all the information in there. So if you take like a typical open API contract, you have details around what is the endpoint name, what is the HTTP method being used, what are the parameters expected within header, within the query, what are the responses that this endpoint will produce. So if they can, this example, for example, this is the GitHub API. It will do like a 200 if everything goes well. And if everything goes well, it will produce a JSON response, which will actually match this schema, which is an array of objects. It will also have these headers in. And if you go like through a typical OpenAPI contract, you'll see that you can specify additional responses, like what happens if there is a validation issue, like you did 400 and or 42 or something else. So it was like, okay, that's cool. So what we can do with it? So because we have all this data, and OpenAPI is now a standard, we can actually apply a set of tools. There are a lot of code, let's say, parsers and generators for OpenAPI in different languages. I've chosen Java for this particular tool. So what happens is that it gets the OpenAPI as an input. It parses it using like the OpenAPI CodeGen library. And after that, you get like an object in memory, which has all the details from the OpenAPI spec. And with that, the initial goal was like, okay, so we have that. Let's just build some requests, which will, so like happy flow requests, which will be sent to the service and see if it works. And that was like the first version was more like a sanity check to see if I have an API spec and I change it. Does the service actually comply with the new spec? And does the service actually, maybe it's backward compatible if you do some API versioning. But after that, we said, like, we can evolve that even more. So like we can actually automate the entire process of the testing. So we can actually generate a test case for that, see what we're actually expecting as a response, because initially it was easy. We had that happy flow scenario. So it's basically expecting a 200 or something around the 200 family. It will run the test case and produce a report. But again, this is a talk about fuzzing. So fuzzing seemed like a natural thing to do after that, because we say that, okay, we have this tool capable of generating something. Why not applying it for all the boring test cases that are usually needed in order to ensure that your API is as secure as possible? So we just fuzz everything now. So we have like this OpenAPI contract, which again is parsed. We get that object, and through that we iterate through all endpoints. And what happens is that for every endpoint and for every HTTP method, CADS will generate like a base payload, which is like a happy flow request. So like whatever is needed for the service to respond, okay. But after that, it applies a set of fuzzers and it iterates through each field and starts introducing different types of values, which based on the scenario being specified by the fuzzer, it will expect the service to either success or fail. And usually it started with boundary testing mostly. So it's like you have like the left boundary and the right boundary, and the fuzzing was happening initially like you send values on the left-hand side and you send values on the right-hand side. And after that, you send some maybe extreme values. So if you take like an integer field, which is part of the contract, and it says it's between 5 and 20, it will send like a 3, a 5, a 6, a 4, a 6, and a 5, so like exact value. And also in the 20 side, it will send a 19, a 21, and a 20. But it will also send like huge values, which we'll check if the service are handling those well. So like it will send the maximum extreme value for the integer, which is quite a big number. It also sends the maximum on the left-hand side. It will even send long values, so even more bigger numbers to see how the application will actually behave with that. And in the end, currently, CADS has around 40 fields fuzzer, how they're called. So a field fuzzer will actually iterate through all the fields within a request. And based on the data type of the field, it will apply all the fuzzers that are matching that data type. So if it's a string, it will apply all the string fuzzers. If it's like an integer or a numeric, there are some generic values for numeric, generic fuzzers for numeric, it will apply all the numeric fuzzers. There are also like 19 header level fuzzers. So it's basically doing the same thing as for the fields, but it applies that to the HTTP header side. And there is another category, which is called HTTP level fuzzers, which is mainly, so initially fuzzing started as a concept, but in order to maintain consistency, some of the checks are actually included into the fuzzer in CAT's sense, but might not actually be fuzzing in the scientific sense, let's say. So the HTTP level fuzzers will actually write some scenarios around bypassing authentication, sending HTTP methods which are not expected by the service, and so on. So under this umbrella, let's say for consistency, we still name them fuzzers, let's say. Okay, now getting a bit lower. This is like the current field level registered fuzzers, just to give you an idea. So this is like what the help will print if you run cats. So just going through some of them here in order to get an idea what is being tested. So we have like the Boolean fields fuzzer, which will send some random strings within a Boolean field to see what happens. We'll have all the left and right boundary fuzzing, which applies for decimal fields, for integer fields, for string fields. There are also fuzzers which will focus on sending null or empty values within the HTTP requests in order, again, to see what happens with the service. Usually it expects, like if it's a required field, it will expect to fail with the validation issues. If it's an optional field, to not do that. Recently, there's also a feature to allow different weird characters, because there were some posts I seen earlier this year around like an emoji breaking an AWS deployment and like a 0 with space breaking some other cloud provider deployment. So there are special fuzzers which are focusing on that, and this is like the control chars, the multi-code point and single code point emojis. Again, they are sent to see how if the actual service is accounting for that. And usually here the expectation is that the service will do sanitization with them. So if it gets a payload which is full of these weird characters, before actually applying the validation, it should actually remove all this before doing that. And cats expect like to receive like a 200 requests if the sanitization is done properly, and if not, it means that it's an issue. And some others, like that also remove field fuzzers, means that out of if you have a payload with 20 fields, it will start remove them one by one, but also in combinations. So like removing 2 and removing 3 fields. So it does like a power set of all the fields. So it's like doing all the combination to remove the fields. On the header side, again, it's mostly the same areas as before the fields, but also implementing some of the recommendation from OWASP, for example, checking the security headers within responses, which again is not a fuzzer per se, but it matches like the wider definition. It checks if how the service will behave with unsupported accept and content types headers. So like if the service will declare that it accepts JSON, it will send XML, it will send URL form encoded, it will send JavaScript, it will even send some dummy accept and content type headers to see what it happens. It will also remove headers, so it's mainly the same areas which are tackled within the fields are also tackled on the header side. And the HTTP side, it's mostly, again, as I mentioned, it's bypassing the authentication fuzzer. So if it detects any authentication header, it will try to remove that and see if all the endpoints are actually responding with like a 401 or 403 response code. It will send like a dummy request to see if you can inject something in there. So if I send a dummy JSON, would it accept it or not? How it would behave? And some additional ones which you can find in the. Now, what are the benefits with this approach? Well, I would say the major benefit is the self-healing capability, because CATS doesn't need anything outside an open API contract and the service endpoint. So if you supply that, all the magic happens within the tool. So all the scenarios, the generation, running those and generating the report, it's out of the box. It also covers all request fields and HTTP headers, which typically might not be easy if you're doing that manually, even if you automate those scenarios. So like if you have like 40 fields within a request, there are probably very few people which will automate all those. I've seen usually people focusing on like the mandatory fields and the mandatory headers and maybe some of the optionals, but not all. But with this tool, because everything is automatic, you get all the benefit of running all the fuzzers against all the fields inside the request. And this is like a huge one, because using this, you can actually cover like all cases which are not easily automated. Now you might ask, well, how about the context? So like, okay, not all services are stateless. Some of them might be, but some of them might need data in order to operate properly. So if you have, again, going with the payments example, in order to do a payment, you need to be boarded with a system. So you'll get like an identifier or something which need to be passed in order to link the payment to your identifier. And in order to accommodate for that, actually CAD support quite a lot of configuration. One of it is like the reference data, how it's called. So it's like a file where we can actually specify it, why it should be static. So like what value you should put instead of being randomly generated. You actually say it's static for all requests. It will still get fuzzed, but when fuzzing other fields, that value will remain static. And there's also some additional, like you can supply authorization through the headers parameters or basic codes or URL params and so forth. It's quite a bunch of settings that you can put here. You can also put rate limiting. You can filter or slice how you run those, because if you run with default, it will actually generate like easily 10 or 20,000 of tests. So it will just do stuff because it goes through all the fields and applies all these fuzzers. It will actually produce a significant number of test cases and tests. So my recommendation is usually to do some slicing, either based on paths. So like first you run the first path, or maybe on types of fuzzers, or maybe on maybe specific types of fuzzing. So like just sending control charts or emojis. Now, the limitation for the tool at the moment is that it's Open API only. It's JSON only. It doesn't do delete points well, because when you do a delete, it will actually perform a server-side operation, and that entity will be gone. So if you delete it once, it's hard to run it again. And there's some work in progress for this one, and kind of pairing it with like a post correspondence, so that you create it and you delete it. There are some complex regex patterns, which if you define in the open spec, the library that is being used to generate data might not be very accurate sometimes, so it might Stack Overflow or something. And there are some issues with checking free map responses. So if the response is defined within the schema, it's like a actual object schema, it's fine. But if like a free map where you can put anything, it cannot check if your response matches the actual schema defined within the contract. Okay, and I have like a small demo for the like a minute or so. So this is like how you run CADs, like it's a typical run. You say the contract, you say the server, you say the header files and the ref data, and you can filter which fuzzers are being run. So in this case, just the right boundary fuzzers. And you can see here how it started running it. So it's like the integer fields, right boundary fuzzer. And in the end, you get like this report with all the execution time, like all the fuzzers which are being run, the scenarios which are being run. So in this case, it's sent that huge value on the right-hand side. So like to see how the application will behave. And you can actually drill down inside each of these rows. So like if you click on it, you'll actually see what was the scenario, what was the expected result, because it sends an out of boundary value, some response details, and the actual payload for like the headers being sent, the payload for request. And this didn't fit into the screen, but it's also the response here.